Okay, this last lesson in Unit 5 is on describing number patterns. We're going to go through a few vocabulary words first. Inductive reasoning is making a conclusion based on patterns you observe. So an example might be, it has rained every day for 3 days. You would maybe use inductive reasoning to say that it would rain the next day or the next 3 days. Doesn't always mean that it's true, but it's just conclusions you base on patterns that you see. A conjecture is just the conclusion that you make. We call it a conjecture. Again, they may be right, they may be wrong, it just depends. A sequence is a number pattern. So 2, 4, 6, 8 is an example of a sequence. A term is a number in that sequence. So any sequence, it's just any number in that sequence. We're going to mainly be talking about arithmetic sequences today. It's a sequence formed by adding a fixed number to each previous term. So if we started with the 2, 4, 6, 8, if we were using that pattern, that is an arithmetic sequence because we add 2 each time. All right, and that whatever it is that we add to each time is called our common difference. And our common difference is the fixed number added to an arithmetic sequence. So it is that number that you add to a sequence each time. So let's look at some examples here. First, we're going to use inductive reasoning to describe each number and pattern, and then we're going to find the next 2 numbers in each pattern. So if we look at the first one, it's 2, 5, 8, 11. Okay, this we are, if you look at it, we are adding 3 each time. So the next 2 patterns, we would add 3 to 11. We would add 3 to 11 and then add 3 more. So we would get 11, 12, 13, we get 14, and then 17. So these would be the next 2 in that pattern. All right, so looking at the next one, it's 2, 4, 8, 16. So we have to figure out what's going on. If you notice, okay, 4 is twice 2, so it doubles 2, and then we double 4, and then we double 16. So to double, that means to multiply by 2. So for this one, we are multiplying by 2. So if we multiply 16 by 2, we're going to get 32, and then if we multiply that by 2, we get 64. So those are the next 2 in that pattern. All right, so the first set of examples is just finding the pattern and then finding the next 2 terms in that pattern. Okay, so looking at example 2. Okay, example 2, it says find the common difference of each arithmetic sequence. So what we have to do, these are arithmetic sequences, which means we're either adding the same number each time. It could be a positive or a negative number. If you're looking at letter A, we're going from -7 to -3. And then to 1, and then to 5. So we are actually going up by 4 units. So our common difference then is positive 4. All right, so it's a positive 4 is our common difference. Looking at letter B, we go from 17 to 13, down to 9, down to 5. So what we're doing is we're actually adding a -4. So that what we're adding could be a negative number, okay? Yes, you do look at it as a subtraction of 4, but that common difference, we would call it a -4, because a -4 says that it goes down by 4 units. All right, so now let's go down to the next page here. Rule for an arithmetic sequence. And the reason we're doing arithmetic sequences right now is because we can create a function, which is kind of what we've been talking about, that will be a rule. It's a function rule that will work for every pattern. Okay? When you're looking at this, you have to understand what each of the little things mean. Okay? Okay, so for A is your first term in the sequence. The N is the term number, Okay, the n is the term number, and then d is your common difference. So in this function, if we have the first term, the term number, and the common difference, we can use this function to find out what the next sequence will be. We can find out the nth term, okay? So in each of these equations or each of these functions, we're going to have a number for a and a number for d, but n will be our variable. That'll be our input. Okay, so what we're going to do for the next example, it says find the 10th term of the sequence that has the rule, and then they give us a rule. Okay, so I'm going to write that down. We have a of n, this is kind of like your f of x right here, equals 32 plus n minus 1 times negative 2. So if you notice, this sequence is going down by negative 2 each time because that is our common difference. That's where the d is. But it asks us to find the 10th term. So what that means is we're going to plug 10 right here in for n. So we get a of 10 equals 32 plus, and then if we put 10 here, it's going to be 10 minus 1, so we get 9 times negative 2. Okay, let's simplify this. We do 32, 9, and then remember we have to do this first. This is multiplication. Positive 9 times a negative 2 gives us a negative 18. So then the 10th term of this sequence is 32 minus 18, which will give us, I believe, 24. Or 14, rather. Okay, so that means the 10th term of the sequence is 14. Now, you can also get the next several sequence numbers too. If I asked you to get the number for term 11, well, what we would do is we'd look at this common difference here. This common difference is negative 2. Okay, so that means that if the 10th term is 14, then we take 2 away from it and we get the 11th term. So the 11th term would actually be 12, and so on and so forth. So you can use that last number in the sequence to know how to get to some of the other terms that you're being asked for. All right, so let's go ahead. Look at the last thing here. Okay, this is called a recursive formula. On a recursive formula, you use next term and previous term to write the pattern. So we base it on next term, okay, and previous term. So we write it, if you look here, we're going 3 to get to 7. To get to 7, we have to add 4 to the previous term, okay? So what we do is we write an equation like this. Next term equals previous term, and then we add 4 to it. So this is a recursive formula where we talk about we have to use the formula where you have to have the next term and the previous term. Okay, or you use the previous term to get to the next term. And this is called a recursive formula, and it's actually written out kind of like that. Next term equals previous term plus 4. And so that's how you use a recursive formula. And that is all of our notes. So this is the last lesson in Unit 5, so we will begin our review and start testing next week. Thank you for listening.